Basically, these are derivatives of the alkanes, but with the halogen atoms. The halogen derivatives of alkanes, and this is their general molecular formula. It is general, but with our discussion, we shall realize that sometimes it is different. You can have when x is 2, when x is 3, the number of the halogens can differ. But generally, we are going to say, let us take this, that format. We together. Then we are saying we are assuming x is only the chloride, the bromide, and the iodide, excluding the fluoride atom. Why do we exclude the fluoride atom? We have said because the fluoride atom is highly electronegative. And because it is highly electronegative, then the carbon fluoride bond becomes extremely polar. And therefore it becomes ionic. Ionic bonds are known for their strength. And since the carbon fluoride bond is strong because of the ionic character, then we realize that it is not easily broken because the reactivity of the alkyl halides depends so much on the ease of the breakage of the carbonyl halogen bonds. If you can break this bond easily, then it means the reaction will easily take place. But since the carbon fluoride bond is strong, and therefore under normal circumstances, the carbon fluoride bond will not be easily broken. And therefore it means the alkyl halides, which have the carbon fluoride bonds, are inert. In fact, they are even non-flammable. There is a notion that we know that most of the organic compounds are flammable, i.e. they catch fire. However, the carbon fluoride bond in any alkyl halide will prevent that compound to be flammable. Means it does not decompose when heated. So that's why when we are talking about alkyl halides, we resist from talking about the alkyl halides of the fluoride atom. I hope that is clear. Now the next thing we can talk about is the classification of alkyl halides. This is dependent on the number of the alkyl groups that are attached to the carbon in the functional group. We are saying that they are depending on the number of alkyl groups attached to the carbon bonded to the halogen. Are we together? So it means they are in this format. Either you can have one alkyl group that is attached to the carbon with the functional group X. We together. So it means in that case, there is hydrogen here and hydrogen here. If there is only one alkyl group attached to the carbon with the halogen, then this one we call it primary alkyl halides. Primary alkyl halides. Primary alkyl halides. If there are two alkyl groups attached, there is R here, then here H, then X. This one is called secondary alkyl halides. Secondary. If there are three alkyl groups attached to the carbon with the functional group, then this one is called a tertiary alkyl halide. Tertiary. Someone might ask, what are these alkyl groups? Because I've been talking about alkyl groups many times, and some people might be confused. When I say R can be CH3. But it can also be CH3, CH2. It can also be CH3, CH, then CH3 here. It's just only a derivative of an alkyl. That's what we call an alkyl halide. Are we together to that level? So basically, an alkyl group is just a hydrocarbon which is a derivative of an alkane. And its general formula is CnH2n plus 1, where N stands for numbers from 1 up to any number that you want. So when I say R, you should not be confused. Just look at it as an CnH2n plus 1. So the alkyl groups are classified into primary, secondary, and tertiary alkyl halides depending on the number of alkyl groups attached to the carbon with a functional group. And because they are classified into these three ways, even their reactivity is different. In most cases, the reactivity of the primary and the secondary alkyl halides is similar and different from that of the tertiary alkyl halide. And we have always said that this reason is because of what we call steric hindrance. We call it steric hindrance. And steric hindrance is simply the hindrance that comes in a reaction because of the what? Of the overcrowding of the molecule. Like for example, when you look at this carbon, it's so crowded by many other alkyl groups. So for the reaction to take place, we have to first reduce the crowding. And how do we reduce the crowding? In most cases, we have to first break off the alkyl, the halogen atom, creating the partial, creating the carbocation. Then the reaction proceeds. That's why the reaction mechanism of tertiary alkyl halides is always different from that of primary and secondary alkyl halides. Remember the other thing we said, most of the alkyl halides undergo what we call substitution reactions. Where the alkyl group is eliminated and replaced by either a nucleophile or an electrophile. Are we together? That's why we had electrophilic substitution reactions and nucleophilic substitution reactions, which are typical for alkyl halides. Now we are saying that we also have what we call aryl halides. Aryl is almost like the opposite of alkyl. Alkyl is just an alkyl. It is a hydrocarbon, but with no ring. But for aryl, now this one, the group that is attached will be having a ring, maybe a benzene ring or any other aromatic ring. Are we together? So in this case, instead of us having Rx, we are going to have ARX, where AR stands for an aromatic ring. For example, e.g., we can have a benzene ring. So this is our benzene ring attached to X, where in this case X stands for either Cl, Br, or I. It stands for those three. Are we together with that level? So it can be in this format, or it can be in this format here. Still, this is our benzene ring. I can put here CH3 methyl group, and then here I put my X. So it depends. As long as the halogen atom is directly bonded to the aromatic ring. If it is like this, then it is not. If it is like this, then maybe CH2X. This is not an aryl. It is not an aryl halogen. It's not an aryl halide. Why? Because the X, the functional group X, is not directly bonded to the ring. Do you see that? It is directly bonded to the carbon atom, which is bonded to the ring. So this is not an aryl halide. However, this one is, because the X is directly bonded to the benzene ring. So I hope now we understand and we can be able to differentiate between those two. Can be able to differentiate between those two. So these are some of the examples. Someone can ask, so what name will you give to these compounds? What name will you give to these compounds? For example, if this one was a Cl, this one will be chlorobenzene. Chlorobenzene. This one will be chlorobenzene. What about this one? This one, the moment you have the CH3 here, this is a methylobenzene. Are we together? But now, the halogen, maybe let me call it Br, let me replace X with Br, is on carbon number 1. So I'm starting to count from here, number 1, number 2, number 3, and number 4. So it means the bromine atom is on carbon number 4. Are we together? Also, somebody can say, I'm going to begin counting from here. I call this one number 1, I call this one number 2, number 3, and number 4. So in that case, the bromide will be on position number 1, the methyl on position number 4. So they can alternate the positions. But which one we mentioned first? The bromine, because B comes before A. Remember we said when we are naming these compounds, we use what we call alphabetic order if you have more than one functional group. So in this case, it shall be, so the bromo will take position number 1. So we begin from here. It will be 1 bromo. Then this is 4 methyl benzene. 1 bromo, 4 methyl benzene. This ring is the benzene ring. Are we together at that level? So when we get to aromatic compounds, we shall see more about the nomenclature of their derivatives. So for now, we can just leave it at that. Then we are also saying that we have what we call dihalides. Dihalides are, in this case, alkyl compounds, alkyl halides with 2 halide atoms. We can have what we call vicinal dihalides. In this case, the 2 halogen atoms are attached to adjacent carbon atoms. For example, e.g., we can have CH3, CH, Cl, then CH, Cl, then CH3. In this case, the halide atoms are attached to carbons that are adjacent to each other. Do you see that? That's what we're saying. The 2 halogen atoms are attached to adjacent carbon atoms. We can have this, we can also have CH3, CH, then CH, 2Cl. The halide atoms are attached to adjacent carbon atoms. What name would you give this? Remember how we named this? This chloride is in position number 2, this is number 3. So it becomes 2, 3 dichloro. This whole compound has 4 carbon atoms, so it becomes butane. 2, 3 to talk about the positions of the chloride atoms. What about this? This one is in position number 1, this is in position number 2, so it becomes 1, 2 dichloro. 1, 2 dichloro-propane. So that's where we are at. So these are some of the examples of what we call vicinal dihalides. We have what we call germinal dihalides. The first one we talked about vicinal dihalides. The second example of dihalides we are calling them germinal dihalides. Germinal dihalides, the chloride atoms are attached to 1 carbon atom in a bond. For example, we can have CH3, C, then Cl here, then also Cl here, then CH3. Do you see this? This one is different from this. Here the chloride atoms are attached to adjacent carbonic atoms. However, here the chloride atoms are attached to the same carbon atom. How would you name this? In the naming you would say this is 2, 2 dichloro-propane. So even in the naming you see that the dichloro atoms are on the same carbon number 2, carbon number 2. So the germinal dihalides, the atom, the halide atoms are attached to the same carbon atom. Now we also have lastly the vinyl halides. Vinyl halides, these ones are derivatives of alkenes. These ones are derivatives of alkenes. Why? The chloride atom or the bromide atom or the iodide atom is attached to the carbon with a double bond. For example, you can have CH3, C, then Cl, then double bond, CH2. How do you name this compound? This one would be 2-chloropropene. To show that the chloride atom is on carbon number 2, but it is a propene. So the vinyl halides are different from alkyl halides. Alkyl halides, these ones are derivatives of alkanes. However, the vinyl halides are derivatives of alkenes because the chloride atom or the bromide atom, the halogen atom, is bonded to a carbon that has what? So these ones cannot be alkyl halides. Just call them vinyl halides. Now let's talk about the nomenclature of alkyl halides. How to name alkyl halides? So we're saying that they are named using the suffix chloro, bromo, or iodo attached to their corresponding derivative of an alkane. Remember we said that alkyl halides are derivatives of alkane. So that means you just make mention of the name of the alkane. For example, if the number of carbon atoms are 2, just say ethane, chloroethane. If there are 3, chloropropane, chlorobutane, like that. However, you must make mention of the position of the halogen, the carbon skeleton. You have to talk about the position of the carbon skeleton. So our examples, we can have this CH3, CH2Br. Of course, you can see bromoethane. So it becomes bromoethane. What about this CH3, CHI, then CH3? Now here, the moment the number of carbon atoms exceeds 2, that means you have to make mention of the position of the halide, because here you cannot say 1 bromoethane because it has to be 1 wherever it is, whether here or here. So now here this is iodo, right? So the position number 2 of the carbon atom, so it becomes 2-iodopropane. Remember, it is one name, so you don't have to put space between 2-iodo. You can see this is the secondary alkyl halide. This is secondary, but this one was primary. I can use a tertiary alkyl halide. For example, if you have CH3, C, and then you have CH3 here, then CH3 here, then this is maybe Cl. How do you name this? The first thing to note is the longest chain. The longest chain, of course, the longest chain is has 3 carbon atoms. Then the chloro is on position number 2, but there is another branch of the methyl. Methyl is also on number 2, right? So what we say there, we say that this one is going to be the chloro is on position number 2 if I come from this side. 2-chloro. but there is a methyl group attached also. It is also number 2, so that is dash dash 2, then 2 methyl propane. Remember what you said. You said these compounds, when you're writing, especially when between a number and a letter, you have to put a slash. You have to always put a slash. All together. What if it is like this? You have CH3, then CH2. Maybe there is a CH3 here, then CH. Then there is a Cl here, right? I can call it a Br. Then CH3. Still it's the same thing. You have to make mention of their position, of their different positions. So in this case, this one will be 2-bromo, because I'm going to begin from this side. I can't begin from this side because the methyl group now will have number 2, then the bromo number 3. Yet you have to follow alphabetical order. So it's gonna be 2-bromo, 2-bromo, 2-bromo. Then now this is gonna be position number 3, 3-methyl. Then the whole chain is butane. Sometimes it might have a benzene ring on it. It might have a benzene ring, so in that case you can have this. Then we have CH2, maybe CH2, then CH2Br. How do you make mention of this? Maybe let me add another one. CH2Br. Or let me make this 3 and then this Br here. We have that compound. This one is still a tertiary, a secondary alkyl halide. This one is a secondary alkyl halide. Even this one is secondary. This one was tertiary. This one is secondary because the carbon with the functional group has 2 methyl groups. 2 alkyl groups. Here the carbon with the functional group still has 2 alkyl groups. Wait together. So in this case, if I'm going to count from this side, 1, 2, 3. So it is a propane, whereby propane has a bromo as a branch. It also has a benzene ring as a branch. So in that case, it becomes 2-bromo. Then the benzene ring, I can attach it to either position number 3, or if I was to begin from this side, this would be 1, 2, 3. So in this case, the phenyl, the benzene ring will be on carbon number 1. So that is better than taking carbon number 3. So that will be 1. Now, when the benzene ring is a branch, we call it phenyl. When the benzene ring is a branch, we call it phenyl. We cannot say benzyl. No, it's going to be phenyl. 2-bromo, 1 phenyl. The longest carbon chain is